You are looking at one of the most complex machines humanity has ever created. It has no engine, no gears, and almost no moving parts. Just a small piece of silicon resting quietly inside a computer system. But hidden inside this tiny object is a world almost impossible to imagine. Billions of microscopic electronic switches are waiting beneath the surface, working together to create the foundation of modern artificial intelligence. Every AI image you generate, every question answered by an AI system, every line of code, translation, or new discovery created with artificial intelligence begins with physical machines like this. There is no magic happening inside. There are only atoms, electricity, engineering, and one of the most advanced pieces of technology humans have ever built. From the outside, an AI GPU looks like a simple electronic component, a small package containing silicon, memory, and tiny connections. But beneath the surface exists an entire microscopic universe. Thousands of layers and billions of structures are arranged with extreme precision. To understand how artificial intelligence works, we need to travel deep inside the hardware that makes it possible. As we enter the processor, the scale completely changes. Structures smaller than anything visible to the human eye become enormous landscapes of engineering. Tiny pathways made from advanced materials connect different regions of the chip together. Inside this world, information is not stored as thoughts or ideas. It exists as electrical signals moving through physical circuits. These electrical signals travel through billions of transistors, the smallest building blocks of modern computing. A transistor does not understand a picture. It does not understand a sentence. And it does not know what artificial intelligence means. Its entire purpose is extremely simple. Control the movement of electricity, switching between different states billions of times every second. One transistor alone can do almost nothing, but when billions of them are connected together, they create complex systems capable of performing enormous calculations. Every AI response begins from these simple physical actions. Small electrical changes, repeated again and again, at a scale that becomes almost impossible for humans to comprehend. A traditional computer processor is designed to complete many different types of instructions. But artificial intelligence requires a different kind of machine. AI needs billions and trillions of mathematical operations, not one after another, but many at the same time. This is where the architecture of a modern AI GPU becomes so powerful. Inside the GPU are thousands of processing structures working together. Instead of moving through a single path, calculations are divided across many different areas. This allows the processor to handle massive amounts of information simultaneously. The secret is not one extremely powerful core. It is thousands of smaller units operating in parallel. Deep inside advanced AI processors are specialized structures called Tensor Cores. These are designed for the mathematics behind artificial intelligence. When an AI model creates an image, recognizes a pattern, or predicts the next word, millions of numerical operations are moving through these circuits. The processor is not thinking like a human brain. It does not understand the meaning behind the information. Instead, it processes huge patterns of numbers, layer after layer, calculation after calculation. The intelligence we experience comes from the enormous scale of these simple mathematical operations. But having extreme processing power creates another challenge. The GPU needs constant access to enormous amounts of data. If information cannot arrive fast enough, even the most advanced processor has to wait. This is why modern AI chips require memory systems built specifically for incredible speed. Beside the processor are stacks of high-bandwidth memory, multiple layers of silicon placed directly above each other. Tiny vertical connections allow information to move through the stack at incredible speeds. The distance between memory and processor becomes extremely small, helping feed the GPU with the data it needs. Connecting the processor and memory requires another incredible layer of engineering, advanced semiconductor packaging. Inside the package, microscopic pathways allow different silicon components to communicate at extremely high speed. The GPU, the memory, and the connection layers all work together, creating a complete AI computing system inside a tiny physical object. These connections are so small that normal manufacturing methods are not enough. Engineers must build structures with extreme precision. Every pathway, every layer, every microscopic connection matters. Because at this scale, even the smallest delay can affect how quickly information moves through the artificial intelligence processor. After billions of components are combined together, the final AI processor is created. Inside a chip that fits in your hand, there are computing engines, memory systems, communication networks, and countless microscopic structures. But this processor is still only the first step in building a true artificial intelligence machine. The AI processor must be installed into a much larger system, a server designed specifically for extreme computation. Around the GPU are power delivery circuits, high-speed connections, control systems, and advanced hardware that allows multiple processors to operate together. One chip becomes part of something much bigger. When many AI processors work inside the same system, they create enormous amounts of computing power. But they also create another major problem: heat. Every electrical operation produces thermal energy, and when billions of operations happen every second, removing that heat becomes one of the greatest engineering challenges. Modern AI systems use advanced liquid cooling technology to solve this problem. Heat moves from the processor surface into carefully designed cooling structures. Liquid flows through precise channels, carrying thermal energy away from the chip. Without this hidden cooling system, these powerful processors could not continue operating. A single AI server is powerful, but modern artificial intelligence requires much more. Thousands of processors are connected together inside massive data centers. Rows of machines operate continuously. Every server, every cable, every cooling system becomes part of the physical infrastructure behind artificial intelligence. Inside these data centers, AI processors communicate with each other at incredible speed. A single task can be divided across thousands of GPUs. Each machine handles a small piece of an enormous mathematical problem. Then all the results are combined together, creating systems larger than any individual computer. When you ask artificial intelligence to create something, you only see the final answer. But behind that moment, electricity moves through silicon, data travels through memory, thousands of processors perform calculations, and an enormous chain of physical events happens inside these machines. Even the largest AI data center can be traced back to the smallest component, the transistor, billions of tiny switches hidden inside silicon, each one performing a simple action. But together, they form processors powerful enough to change how humans create, communicate, and solve problems. Before these chips ever reach a server, their journey begins inside semiconductor fabrication facilities. Some of the cleanest and most advanced factories on Earth. A single particle of dust can destroy microscopic structures. So every step must happen inside a carefully controlled environment. Inside these factories, silicon wafers move through hundreds of complex manufacturing steps. Machines create patterns smaller than anything humans can build by hand. Layer after layer, the circuits begin to form, slowly transforming a simple piece of silicon into an advanced processor. After the microscopic circuits are created, the processor die must leave the wafer and enter another stage of engineering. Advanced packaging combines the GPU with high-speed memory and communication layers. Each component must align with extreme accuracy. Millions of tiny connections come together, turning separate pieces of silicon into one complete AI processor. The final chip may look similar to the object we started with, a small piece of advanced technology sitting quietly under laboratory lights. But now, we understand what exists inside. A hidden world of transistors, processing systems, memory structures, and engineering created at a scale almost impossible to imagine. From microscopic electrical switches, to powerful processors, from individual servers, to enormous artificial intelligence data centers, every layer is connected, every part depends on another. Artificial intelligence is not only software running somewhere in the cloud. It is a massive physical machine built from human engineering. The systems behind modern AI require some of the most advanced technologies ever created. Semiconductor manufacturing, precision materials, high-speed memory, advanced cooling, and thousands of processors working together. Each answer generated by artificial intelligence is supported by decades of scientific and engineering progress. So the next time an AI creates an image, writes a program, or answers a question in seconds, remember what is happening behind the screen. A universe of silicon is working. Billions of tiny switches, thousands of powerful processors, and countless calculations happening faster than we can perceive. This small piece of silicon cannot think by itself. It does not have imagination, and it does not understand the world like humans do. But through physics, mathematics, and engineering, humans have transformed simple electrical signals into one of the most powerful technologies ever created. This is the hidden machine behind artificial intelligence.